Question 4. Show that the equation 3 sine squared theta minus 2 cos squared theta equals 1 can be written as 5 sine squared theta equals 3. So we want to get rid of this cos squared term and write it in terms of sine squared. So the fundamental relationship that we're going to use is that sine squared theta plus cos squared theta is always equal to 1 for any angle. So that means that cos squared theta can be written as 1 minus sine squared theta. And now I'm just going to substitute for cos squared theta in the equation. So we have 3 sine squared theta minus 2 cos squared theta equals 1. 3 sine squared theta minus 2, and instead of cos squared I'm going to write 1 minus sine squared. Is equal to 1. Take off the brackets and we get 3 sine squared theta minus 2 times 1 is minus 2. Minus 2 times minus sine squared theta is plus 2 sine squared theta equals 1. So I've got 3 sine squared theta plus 2 sine squared theta is 5 sine squared theta is equal to 1, and if I take the minus 2 at the other side it becomes plus 2, and that gives us the required result. 5 sine squared theta is equal to 3. Moving on to the second part of the question. Hence solve for theta between 0 and 360 the equation 3 sine squared theta minus 2 cos squared theta equals 1, giving your answers to one decimal place. So we can rewrite this equation as 5 sine squared theta equals 3. So sine squared theta is equal to 3 divided by 5, which means that sine theta is the square root of that. But we've got to be careful here because it can be plus or minus the square root of 3 over 5. Students often seem to forget that when you take the square root of 3 over 5, you can also have minus root 3 over 5 as an answer. And we'll find here that this will give us 4 roots to the equation. And to get them, I'm going to use something called a cast diagram. But first of all, I'll say that theta, one value of theta, is sine the minus 1 of root 3 over 5. And if we put sine the minus 1 root 3 over 5 in a calculator, we get 50.8 degrees to one decimal place. Now the cast diagram looks like this. And we've got all of the trigonometric ratios are positive in that first quadrant from 0 to 90. Then sine is positive in the second quadrant, tangent is positive in the third quadrant, and cosine in the fourth. So each of the trigonometric ratios gets 2 quadrants in which it's positive and 2 in which it's negative. They're all positive 0 to 90, and then 1 each in the next 3 quadrants. And you can see why we sometimes call it a cast diagram, because it spells cast if we start here and work our way around. Now then, 50.8 degrees. What we do is we make an angle of 50.8 degrees and label it, and then another angle of 50.8, and these angles are always made with the horizontal axis. So another one here, and another one here. Now usually there would only be 2. If sine theta had to be positive, I would have just done it in those 2 where sine is positive. But because it can be negative in this question as well, I've put it in the 2 quadrants where sine can be negative. And this will let me read off all 4 answers. There's the first one, 50.8 degrees, which I've already written down. The next one Measuring from 0 anti-clockwise to here, that would be 180 minus 50.8. So that's 129.2 degrees. And the third one, come around from 0 anti-clockwise all the way around to here, and that's 180 plus another 50.8. So that's 230.8 degrees. And the last one is a full circle except for the last 50.8 degrees. So that would be 309.2 degrees, 360 minus 50.8. And that completes the 4 roots of this equation.